This is an annual GIS industry conference. At this conference, we will share the latest GIS technologies and wonderful solutions from various countries. So what new progress has SuperMap made in GIS technology in the past year? In this report, my colleagues and I will give you a detailed introduction. Our report will be divided into 4 parts. The first report is the evolution of new generation 3D GIS technology, both by me. And next, my colleagues Bill, Jeffrey, and Qin will bring you the latest progress reports of game engines, terminal products, and cloud products, respectively. All right, let's start the first report. Evolution of new generation 3D GIS technology. I will explain the new progress of SuperMap 3D GIS from 3 parts. They are data fusion, WebGL, and XR. So the first topic is new progress of multi-source data fusion technology for 3D real scene. The main point of this topic is multi-source data fusion. But before we discuss it, I want to introduce what is 3D real scene. 3D real scene is a new goal put forwarded by Chinese government when it enters a new stage of surveying and mapping information industry. I found the detailed definition of 3D real scene on the website of the Ministry of Natural Resources. It is the digital space that reflects and expresses the real 3D and sequential human products, production, life, and ecologic space within a certain range. It is a standardized product of new fundamental surveying and mapping, an important new national infrastructure, and provides a unified space for economic and social development and informatization of various departments. In the construction of 3D real scene, the Ministry of Natural Resources has issued a series of notices and documents. In addition of 3D real scene China, in addition to the notice of comprehensively promote the construction of 3D reals in China issued by the Ministry of Natural Resources in February this year, new fundamental surveying and mapping and 3D reals in China construction technology documents 1 to 4 and 5 to 7 were issued in December last year and April this year. So under the tide of national policy and market, SuperMap has carried out a lot of construction work of 3D reals in China in recent years. In these works, we find that the construction of 3D real scene faces some challenges. So today, let's take a look at the challenges and how we can deal with them. The first one is how to convert stock point line area data to 3D. In our actual work, we found that various departments have accumulated a lot of geographical data, but most of this geographical data are 2D points, line, and area vector data. So how can we use this stock data? We started to build a 2D and 3D integration GIS platform very early, which is to solve the problem of inheritance and development. For example, render points into trees, render 2D lines into railway models, symbolize 2D surfaces into water surface, and render 2D network data into 3D pipeline network models. In recent years, we have developed from symbolic modeling to parametric modeling, which is another way with higher efficiency and more powerful functions. For example, internal modeling, we can directly create a tunnel model by setting the tunnel line, texture parameters of each surface, cross-section extra, then we can create the terminal model with those parameters automatically. And the second challenge is how to build an analyzable and computable 3D geographical entity object. Taking the geographical body as an example, we can carry out various analysis and operation based on this module, such as section analysis or profile analysis, excavation, dig a hole, etc. These functions are based on the geometric operations of the model body. In addition, there are many other rich 3D spatial analysis. For example, visibility analysis allows us to analyze whether 2 points are intervisible or not. Skyline analysis allows us to extract the skyline of the city. Openness analysis allows us to quantitatively calculate the openness of a certain point, and others. At the same time, taking the same platform of Yuan new area as an example, we have also summarized many intelligent management rules in urban planning in practice, such as building setback can help us to analyze the distance between building and road and check whether it's too close or not. The total underground construction area and total above ground construction area can automatically calculate the area of building underground and underground. Okay, then next, let's talk about how to integrate geographical entity objects with different accuracy in 3D scene. In the process of 3D real scene construction, we collected various 3D GIS data with different formats, accuracy, and users. However, 3D real scene requires this data to be uniformly displayed in the GIS scene. Therefore, how to integrate data from different sources has become an important problem to be solved. So these are some of our achievements. We can overlay the oblique photography with the vector road and overlay the oblique photography embedded with terrain, and beam can be embedded oblique photography, and also beam can embed with terrain. And in particle application, we can modify the terrain to fit the model data. This is a model of dam. When we want to integrate the dam model data with the terrain, we need to modify the terrain to let it be suitable with the dam model. Also, we can modify the terrain to build revestment to better display the road data in beam format. When we want to create or construct the road on the mountain, we always need to modify the terrain to be suitable to the beam model. Okay, next challenge is how to manage massive 3D real scene data. SuperMap Geo-processing tool provides some new functions for 3D data management. On iDesktop X, you can achieve the PA file creation and adjustment, and on a server, you can publish the PA file and reuse it on website. So let me show you some demonstration. In this video, this is a terrain data processing automation workflow. You just need to set the parameters like the path of terrain data. Cache setting includes path of cache file, path of .sct file. Then the terrain can be published as 3D service automatically. We can view the 3D terrain on the web. And for oblique photography, it's the same. All of the processing steps can be done automatically after setting parameters. With this function, we can automatically add 3D data. For example, for smart city project, we don't need to manually process new data every time when we add it, but users can directly add it to the system for management and sharing after collecting data. BIM data can be accessed to PA process from BIM software to realize automatic export, cache cutting, and release of BIM data. Users can browse the published BIM data directly on the web. We can see from the video, after we run the process, we can view the BIM model on the web in a correct location. The next challenge is how to render massive 3D real-scene data efficiently. This year, we upgraded the S3M format from 2.0 to 3.0. It supports geometric compression and texture compression, greatly reduce the amount of data, and meet multi-terminal applications. And it has more precious clipping and scheduling strategies like support OBB bounding box, optimize S3M layer scheduling strategy, and add LOD switching mode. After testing, the video memory occupation of S3M 3.0 is reduced by 30%, and the loading performance is improved by 140% to 200%. Here are two demos showing that S3M can smoothly render a large amount of oblique photography data and white mode. Okay, the last challenge is how to share and publish 3D real scene. The 3D real scene data is divided into 3 levels: terrain level 3D real scene, city level, and component level. And each level corresponds to data in different formats. For example, 2D expression geographic entity, 3D expression geographic entity, DEM, and other data are the main components of terrain level 3D real scene. And oblique photography, point cloud, model, and other data are the main components of city level 3D real scene. However, the components 3D real scene is mainly composed of fine model and BIM. So for so many data in different formats, we can use different service interface to connect and publish them to the GIS server. The National 3D Spatiotemporal Database has collected and managed 10-meter terrain data for the whole country, which are 9.6 million square kilometers, and 2-meter terrain data over 60% of China, which is 5.76 million square kilometers. And besides, and the above ground and underground data of oblique photography, urban precision modeling, underground pipelines, underground space, and underwater terrain in some polluted area. This is the achievement and application of 3D reals in China for now. All right, now let's go to the second part of my presentation. In this part, I will introduce the new progress of WebGL client technology, which is a high fidelity 3D web rendering engine. Generally, 3D web rendering engine needs to meet the following 5 points in order to have the ability of realistic rendering. They are PBR materials, particle systems, light and shadow effects, and post-processing capabilities that are becoming more and more mature on the web. At the same time, for 3D GIS, we also need to have the ability of weather simulation and other open worlds. So in addition to this capability, we also need to provide standard description file to reduce the difficulty of users. We provide JSON format file such as materials and practicals. On another hand, a large amount of materials and other resources have been accumulated in in the game industry, such as UE or Unity. Based on this situation, one of our important work is to get through the complete process of exporting PBR materials from platforms such as UE or Unity and loading materials on the web, so as to make full use of these PBR materials resources and improve the beauty of the scene. On the other hand, we also plan to provide some editors to meet users' personalized needs and improve users' development efficiency. So first, let's learn how to use game engine materials in the client. This video shows the effect of the web model PBR materials exported by UE and loaded on the 3D WebGL client. It can clearly feel the differences between the light and shadow effects of different materials of walls and windows, as well as the realistic display during the day and night. At the same time, our browsing is also very smooth and meets the real-time performance requirement. Next, let's take a look at the implementation of this rendering method on the website. So for the light and shadow effects, the environmental mapping means in PBR material, diffuse and specular ambient light maps are supported. You can see the skybox reflected on the glass and the lighting effect. We also support the real-time shadow effect of following the sign's position under S3M layer. In weather simulation, physics-based atmospheric scattering solar diffuse reflection. First, follow the time and the position of the sun, and based on the physics atmospheric scattering effect, truly simulate the atmospheric and sky effect. This is the effect of simulating rain, including the particle effect when it rains and the puddle effect on the ground. And this is the effect of simulating snow, including the effect of particles and snow on the ground. And for post-processing effect, this is a demo of screen space reflection. The street after the rain reflects the building on the ground. 3D WebGL client also need to support full data and full functions. At the data level, we support all kinds of mainstream data, from massive multi-source 3D models, field data, image service, and industry-specified data, such as geologic bodies. In terms of function, we support contour lines of terrain, filling and excavation ability, spatial query, spatial analysis, attribute query of 3D data, Boolean operation, spatial relationship judgment, etc., as well as various interactive operations such as measurement, rendering, editing, and clipping. Now I would like to share with you some related functions in the past year. Enhanced the display effect of real scene 3D model based on image data. using the undistorted oblique photography. The camera's air altitude corresponding to each image is calculated in the 3D scene, and the image is superimposed. Oblique photography model can overlay and display REST map service, and can also obtain the altitude attribute information of objects through data service, so as to realize the integrated management of 2D and 3D assets. The flooding analysis considers connectivities and support the effect of water surface reflection. This is a new method comparing with the earlier flooding analysis. And support the net CDF format data and support the gradient, color transparency, clipping, and timing. This is an ability to extract ISO service through grid. And the terrain excavation function we realize in a new way. We can not only dig a hole in the terrain, but also lift up the excavated part and display it separately. It can be expressed on the blank plot and grow the model dynamically also. And next is a very cool effect. This is to simulate the effect of model explosion and to show the local details and the layout of the space in an exaggerated way. And also the front end can directly support the .DAE and .x model format. That means we can dynamically to modify the 3D scene on website. And we also support the clipping of image data. According to the specified irregular area, only the image data in this area is displayed. This video shows the image data in different administrative regions. And the demo shows the effects of stylized rendering of the frame of the building, and realizes a pencil drawing effect on the sketch. All right, and also we have made some new progress in local development. In 2021, we completed the update of Vue 2.0 to 3.0. This year, we will also launch the framework of React. And this is an intervisibility analysis function under Vue components. Developers can use SuperMap Icon 3D for WebGL to develop 3D web application more conveniently. And the last part of my report is related to XR, which is the general term of VR, AR, and MR. Many people say that this will be the technical foothold of the metaverse. GIS is an indispensable link in the metaverse because it can provide data support for it. Then let's take a look what progress SuperMap has made in this part. The first one is VR, which is virtual reality. As we all know, the SuperMap iDesktop already supports the VR glass several years ago. So this year, we have added a new supported device, which is Oculus Quest 2. And we can see for the fine model rendered in SuperMap iDesktop, we can wear the VR glass to be inside of it. And also, our game engine plugin supports VR. In this way, we can browse the 3D GIS scene rendered by the game engine in VR eyes. This video is one of our real projects, the Fuzhou Xiamen Airport. And next is about AR, the augmented reality. One of new progress of AR is the rendering of PBR materials. This is the materials exported from game engine, and it can show a very real way of the pipelines. Besides of which, our AR products also support depth API. You can see we can render the pipelines on the ground, but if there is an object in front of the model, we can hide this part of model. Here I'm going to show you a video about our real project, which is the pipeline AR project. You just need to scan the QR code, and you can get the detailed information of this hole, and you can render all of the pipeline objects in your mobile camera. At the same time, you can click any of the objects to query the detailed attributes of it. The last one is MR. The MR is mixed reality. Here, this is a video about MR. We can climb the mountain Kumulangma in the office. All right, thank you for your time. This is the content of my part. Next, I will give the floor to my colleague Bill to talk about the game engine. Bill, floor is yours.